These examples come from the greatest common factor level 1 section of Delta Math. So this would be our assignment for today. Your instructions say factor the expression completely, which just means you want to make sure you take the greatest common factor and not just any common factor. So remember, greatest common factor we know better as GCF. That's what we call it in action, which stands for greatest common factor. All right, and remember, it's the biggest number that both of your numbers have in common. We typically do this on Desmos using the GCD feature, and then you put your first number, comma, your second number, and it'll spit out the greatest common factor. Ultimately, what's happening with greatest common factor is you take your two numbers and you make a list of all the things that multiply to be that number. So like 1 and 15, 3 and 5 for 15. For 12, it's 1 and 12, 2 and 6, and 3 and 4. So all of these numbers multiply to be these, and we're looking for the biggest number that appears on both lists. So although 1 appears on both lists and it is a common factor, 3 is the biggest number that both of those have in common. So that's our GCF. If I were to do this one on Desmos, it would look like GCD. I would type in 15, 12, and it would give me equals 3 as well. Okay, you can see that in action right here. This would be what it looks like in class. If I type in GCD and type in 15, 12, it'll pop out that it's 3, just to confirm our answer. So I write that down as my GCF, and then we have to divide that out. So I'm going to divide each of these terms by that GCF that we decided on. So 15 divided by 3 is 5. I can bring the x down. Negative 12 divided by 3 is negative 4. And that should make my final answer. You can check it by multiplying and just double checking. 3 times 5x is 15x, 3 times negative 4 is negative 12, and that one does check out. Now, Delta Math also sometimes puts these backwards with the variable in the back. It doesn't change how it works. So if I was going to do this using Desmos, it would look like GCD 36, 27. And Desmos should tell you that your GCF is 9. So I'm going to start with 9, and I'm going to divide that out of both pieces here. 36 divided by 9 is 4. 27 divided by 9 is 3, and this x will just come down. And that makes this my final answer. Now, some problems only have a GCF that's a variable. So here I have 6 and then a 1 that's here. So if I type in GCD 6, 1, it's only going to equal 1, and dividing out 1 isn't going to do anything. If you feel better writing it, then that's cool, but both of these really just have x's in common. So when it comes to variables, you want to choose the smallest exponent. It's like saying x squared has x, and x to the first power, which is what this one is here, we have just an x. So we're figuring out how many x's they have in common, and that's just a single x. So we'll take x and put that on the outside. You can put the 1 there if you so choose, but it's not really necessary. So I'm going to take that out of there. So I'm going to end up dividing by 1x, or just plain x. So the 6 will come down in parentheses. And here's where we use our exponent rules for division. 2 minus 1 is just 1. Here I have a 1 in front of this, so I am going to bring that down because x and x, 1 minus 1 makes no x's. So I do have to make sure that I include a 1 there. But that makes my final answer.